Hello, this is Mr. Win, and this video is over line segments on a coordinate plane. Also a reminder, remember that answers may always involve fractions, so when you're solving an equation for a variable, let's say x, you could get a fraction answer. When you plug it in, you could also get another fraction answer. But in this video, I am using nice whole numbers for simplicity. So the coordinate plane is a two-dimensional plane. Since there are two pairs of opposite directions, you know the x-axis as left or right, and the y-axis is up or down. In a sense, it is basically two number lines. Like before, we can find the distance and midpoint. Remember that now, since it's 2D, each point must have two numbers to tell its location. This is known as an ordered pair. Also remember the x-coordinate comes first. So in this picture, notice point A is located at 5, 2 because it went right 5 from the origin and up 2. So to find distance between 2 points on a coordinate plane, you have two options. Also, note 1, remember distance is just a single number, not a point. And note 2, you can never manually count to find the distance of a slanted or diagonal segment. You can only count spaces on horizontal and vertical segments. So it says find the distance between point A, which is at -2, 3, so left 2 up 3, and point B, which is at 2, 6, so from origin right 2 up 6. So here's the line. We're trying to find how long that is. Again, you cannot count this at all. And also keep in mind, distance involves subtracting the like parts. So our first option is the distance formula. So d equals square root of x2 minus x1 all squared plus y2 minus y1 all squared. Notice this x2 minus x1 came from the distance of the x number line. This y2 minus y1 comes from the distance of the y number line. Alright, you label your points x1, y1, x2, y2, fill them into the formula, and then simplify. So let's call -2, 3 x1, y1 and 2, 6 x2, y2. When you fill it in, make sure you know you're starting negative. That makes positive 4. That's just adding, so 2 plus 2 is 4. 6 minus 3 is 3. You have to square the inside. 16 plus 9, that's 25. When you square 25, you get 5. So the distance from A to B, or the measure of A to B, is 5 units. Right, option 2 is the Pythagorean theorem. So that's a squared plus b squared plus c squared. What you're going to do is you're going to draw one vertical and one horizontal segment, which then, when combined with the original, creates a right triangle. A and B are the horizontal and vertical lengths, and you can count those because they're horizontal and vertical, they're not slanted. And C is the hypotenuse, which will always be our distance. So here's the picture. Alright, notice I drew this right segment, and then this down vertical segment. So I count them from A to this is 4 spots, because there's 1, 2, 3, 4. From here to here is 3 spots. And then our hypotenuse is going to be x. Alright, so A is 4, B is 3, C is x. And you can also reverse A and B, it doesn't matter. But x or C has to be the hypotenuse. We fill it in. 4 squared plus 3 squared equals x squared. Square 4, you get 16. Square 3, you get 9. Equals x squared. Combine like terms, you get 25 equals x squared. Square both sides, you get 5. And that's it. Alright, fractional distance also appears in the coordinate plane. When doing it here, always remember to do the x's and the y's separately. Follow the exact same steps as before. So find the point that is 2/3 the distance from the point 2, -6 to 11, -3. Here's a picture, not drawn to scale, so a sketch. So we're starting at 2, -6, we're going upwards until we reach 11, -3. But we're actually finding the point 2/3 of the way up there, so we're finding this mystery point. The steps we forgot from before is find the entire distance, although we're doing the x's and y's separately. Multiply those distances by the fraction, then add that new number to the appropriate coordinate in the original starting location. So we'll do the x's first. So I found the distance, so 11 minus 2 is 9, after value of 9 is still 9, so it's 9 units. So from 2 to 11 is 9 spaces. I'll multiply the fraction. 2/3 times 9. So 2/3 times 9 over 1. That's 18 over 3, which reduces 6. Then I'm going to add it. So 2 plus 6 is 8. So this is the x part of the coordinate 2/3 of the way. Same idea for the y's. So -3 minus -6. That's really -3 plus 6. That's positive 3. Obviously positive stays positive 3. Multiply that with a fraction. And then I'm going to add that number to the starting y coordinate. So -6 plus 2 is -4. So this is the y part of the coordinate 2/3 of the way. Do not forget to combine your two answers together as an ordered pair. So 8 and -4 is the point, 2/3 of the way up. That should make sense. So it's 2/3 of the way for the x's, it's 2/3 of the way up for the y's. Alright, also when taking square roots, sometimes the number inside isn't completely square rootable, meaning it's not a perfect square. In that case, the answer is an irrational number. That means it is unable to be represented as a whole number, fraction, or even as a terminating or repeating decimal. Keep it in your answer, but be sure to simplify if possible. And know that irrational terms do not combine with non-irrational terms. So for example, what is the square root of 16? Well, hopefully you know the answer is 4, because 16 is a perfect square. But here's how you actually get 4 by doing the math. Hopefully I learned the tree branch factoring method. So I'm going to break down 16 into 2 times 8, and I crossed it out because I broke down. 2 is prime, I'll leave it alone, but 8's not. I'm going to break down into 2 times 4 and cross it out. 2 is prime, 4 is not. I break down 4 to 2 times 2. But you should end with these 4 2's. You want all the prime numbers. Then you're going to circle pairs. So here's a pair of 2's, here's a pair of 2's. For every pair, one number goes out. So a single 2 came up from the first pair, a single 2 came up from the second pair. Since there's no unpaired numbers, the square root sign's gone. You multiply the outsides to get 4. Alright, so now I'm going to try the same idea for square root of 24. So let's see what the square root of 24 is. Well, you should not know what it is. If you type in a calculator, you get 4.898979486. It keeps going forever. Alright, just a reminder. You are never ever allowed to use a round in my class unless a question specifically asks for a round answer, which if I'm making the test, it won't be by me. Alright, all answers are expected to be fully reduced and exact, so get used to using fractions. So let's try square root of 24. Let's break it down. Square root of 24 turns to say 6 and 4. You can also do 2 and 12 or 3 and 8. It does not matter as long as you get 2 correct numbers and multiply 24. The 24 crossed out. 6 breaks down into 2 and 3. They're both prime, but 6 is gone. 4 breaks down to 2 and 2, and that's gone. And those are all prime numbers. Oops. Alright, so now I find the pairs. Well, there's only one pair, a pair of 2's. So for that pair of 2's, a single 2 goes on the outside. Now these non-pairs stay inside the square root. Whatever's outside multiplies together like before, but it's a single thing. Whatever's inside multiplies together. So 2 times 3 is 6. So 2 squared 6 is the same answer. So if I compare that to square root of 24, 2 squared 6 enter, I get the same 4.8989 number. So this is kind of like reducing a fraction. We're simplifying a radical. Alright, and last, you are allowed to keep an answer as 3 plus 4 root 7. Alright, these do not combine. This square root sounds kind of like x. Alright, so that is the perfect good answer, even if it's like an x coordinate or a y coordinate of a point. Alright, so rational numbers do not combine with irrational numbers. Alright, we can also find midpoint of 2 points on a coordinate plane. You have 2 options. Remember to do the x's and the y separately, as the answer is an ordered pair. So find the midpoint of -2, 8 and 6, 10. Also remember, midpoint involves averaging the like parts, so adding and then dividing by 2. So we of course have a formula. The midpoint m is, for the x part, is x1 plus x2, then all over 2, comma, so separate. Then the y midpoint, part of the midpoint is y1 plus y2, all over 2. So you just label your points x1, y1, x2, y2, fill in the formula and simplify. So that's how I'll label it. -2 is x1, 8 is y1, 6 is x2, 10 is y2. I fill it out. Then make sure you always reduce your final answer. So we get 2, 9, and that is our answer. 2, 9 is the midpoint. Alright, because 2 is in the middle of -2 to 6, and 9 is in the middle of 8 and 10. Now the second option is my favorite. It's called the Eme chart. It's a common sense chart where E stands for endpoint, M stands for midpoint. You just fill in the chart and find the pattern. Treat the x and y sides separately. So if the midpoint is missing, find the average or halfway number. So what's halfway between -2 and 6? Well, unfortunately, I just do the average in our head. So -2 plus 6 is 4. 4 divided by 2 is 2. So 2 is the middle there. And what's halfway between 8 and 10? Hopefully you know it's 9. Alright. But one nice thing is this. Check if the pattern works to ensure the correct answer. So we check the left side. How do you go from -2 to 2? You have to add 4. Then you have to add 4 again to get 6, because the middle means the same distance away from both sides. Alright, the other side. How you go from 8 to 9, you add 1. Then from 9 to 10, you add 1. So plus 1, plus 1, good. The pattern maintained. Alright, so here's another example. Sometimes you're given an endpoint and a midpoint, and you have to find the other endpoint. You can use the same 2 options before, but the formula looks a lot messier because you have to work backwards. Alright, so find the missing endpoint if one endpoint is 5, -9, and the midpoint is 7, -15. Alright, so the formula, we need to split it this time because we have the x part and the y part of the formula, the midpoint, but we don't have x2 or y2. So now we're going to label our points x1, y1, mx, my, fill them into the split formula and solve for x2 and y2. So here's x1, y1, and here's the midpoint x part, here's the midpoint and y part. Those subscripts just mean which side they are. So for the x's, I fill it in, I get 7 equals 5 plus x2 all over 2. To get a fraction, you have multiply both sides by the denominator. I'll multiply both sides by 2 to get 14 equals 5 plus x2. Get x2 by itself by subtracting 5, you get 9, and that's it there. For the y, same idea. I fill it in, get rid of the fraction by multiplying both sides by 2. Negative 30 equals that. Get rid of the negative 1 by adding 9 both sides. We get that. Don't forget to put it together as an ordered pair. So 9, negative 21 is the endpoint. Now what's faster, and why it's my favorite, is this Eme chart. So again, just use common sense. If the endpoint is missing, just continue the pattern. Be careful of the signs though. So how do you go from 5 to 7? You have to add 2. Well, if it's 2 away from 5, it has to be 2 away from the other thing. So I'm going to keep the pattern. Plus 2 again. 7 plus 2 gives us 9. Then over here, how do you go from negative 9 to negative 15? Well, you're actually subtracting. You're subtracting 6. You're getting smaller. So I have to maintain that pattern. So minus 6 again. Negative 15 minus 6 gives you negative 21. That's the answer there. Alright, that's it for the video. Hope you enjoyed it. Make sure to ask any questions. Thanks for watching. See you soon. Bye.